Hello class! Today we're going to decipher the spheres. There are two formulas that we're going to learn and apply. One is for the volume, the other is for the surface area of our sphere. Let's take a look at some of these vocabulary words that we need to know. So, a sphere is a locus of points in space that are a fixed distance from a given point. And that given point is called the center of a sphere. What makes this different from a circle, and I don't like that S there. What makes this different from a circle is it's a locus of points in a plane that would be flat. That's a circle, but in space that means it goes three-dimensionally. And a radius of a sphere connects the center of the sphere to any point on the sphere. So a hemisphere then is half of a sphere, and a great circle divides the sphere into those two hemispheres. So now that we've got these vocabulary words defined, see if you can put those words onto the blanks here. Give it a pause and put the words on and then come back and check it out. I bet you did great, because I know you guys are smart. Let's move on. The figure shows a hemisphere and a cylinder with a cone removed from its interior. The cross sections have the same area at every level, so the volumes are equal by Cavalier's principle. I can never say that name. And we could prove that, and if I assigned you something out of the book from number 39, we would do that. But just take a note here that the height of the hemisphere, right there, is equal to the radius. So we have a formula for the volume of the sphere, and that is this volume is equal to 4/3 pi r cubed. And we are going to be using that one to find our formula. So volume is equal to 4/3 pi r cubed. So here's an example where we're going to find the volume of the sphere. The information that they gave us on the sphere, though, is not a radius. This is a diameter. So if that's a diameter, the radius is going to be 1/2 of the diameter, or 12. So we'll use that formula. V is equal to 4/3 pi times the radius, which we found was 12, and that's going to be cubed. So when we put that in there, let's leave it in terms of pi first. Or yeah, let's just leave it in terms of pi. 2,304 pi, and our unit is inches, and of course it's volume, so it's cubed. In this particular example, they're not asking us to find the volume because they gave us the volume, that it's 36,000 pi centimeters cubed. They want the diameter. Now, the volume is equal to 4/3 of pi r cubed. So let's put what we know in there. So it's going to be 36,000 equals 4/3 pi. Oops, there's a pi in here too. Forgot that pi right there. r cubed. Now I want to clear this 4/3, so I'm going to multiply by its reciprocal 3/4 on both sides. That 3 will cancel this 3. This 4 will cancel that 4. And so I have 3/4 times 36,000 pi. That gives me 27,000 pi. And that's going to equal pi r cubed. Let's divide by pi. And that will cancel out on both sides of the equation. So we're going to have r cubed is equal to 27,000. So I'm going to take the cube root of both sides of the equation to give us simply r. And the cube root of 27,000 is 30. Now, that's not what they were asking. They want the diameter. This is the radius. And the diameter is twice that. So if I were to multiply that by 2, I'm going to have the diameter is equal to 60 centimeters. On this example, they're asking us to find the volume, but they're not asking us to find the volume of a sphere. They want a hemisphere. Hemisphere is half. So we're going to find half of that volume. So we're going to take the volume is going to be 1/2 of 4/3 pi r cubed. Just to be, make this a little simpler, the 2 goes into 2 once and goes into 4 twice. So that's really 2/3 pi r cubed. So let's put in our radius, which is 15, and we'll cube that. And when we do all that, we get 2,250 pi, and we're going to put the unit on it, meters cubed. In this application, we're going to look at 2 different balls, and we want to see how many times bigger the jumbo ball is from the volume of the standard ball. So we have to find both of those. So let's first look at the standard ball. It has a diameter of 22, so its radius is half of that, 22 divided by 2, or 11. So its volume will be 4/3 pi 11 cubed, which gives me approximately, and we're going to use the pi, instead of leaving it in the answer, we're going to actually calculate with it, and that's going to be 5,580 cubic inches. Now the jumbo ball has a radius that is 34. So, it's going to be, the diameter is 34, so we need to divide that in 2, and that's going to give us 17. So our volume for this one is going to be 4/3 pi times 17 cubed. So using our calculators, we're going to find that it's approximately 20,580 inches cubed for its volume. So if we want to find how much greater this one is than this one, we're going to take 580, and we will divide it by 5,580. And so that gives us approximately, let's go 1 decimal place, 3.7. So we would say a jumbo ball is about 3.7 times as great in volume as a standard ball. The other formula that we're going to learn with a sphere is the surface area. So if you look at this figure, the vertex of the pyramid that's drawn inside the sphere is at the center of the sphere. The height of the pyramid is approximately the radius of R of the sphere. And suppose we fill the entire sphere is filled with a number of pyramids, we'd call that N, that each have a base B and a height of R. So if we were able to have the pyramids fill the sphere, the total area of the bases is approximately equal to the surface area of the sphere, S. So we are able to derive the surface area formula as 4 pi r squared is approximately equal to S. As the number of pyramids increases, the approximation will get closer and closer to the actual surface area. And so we come up with this formula then for surface area and in here it says S. I often will just do SA for surface area. That's going to equal 4 times pi r squared. This is squared, not cubed, because it is one-dimensional. Even though we're doing the surface area of this circle, it's something we could lay flat. So let's take a look at this example. They're asking for the surface area of a sphere. Now they told us the diameter is 76, but we want the radius. So the radius is going to be 76 divided by 2, or 38. So our surface area is going to be 4 times pi times that radius that we found is 38 squared. And it's going to be in terms of centimeters. So in terms of pi, then we'll 38 squared, and then we'll multiply that by 4, and we'll have 5,706 pi centimeters squared for our surface area. In this example, they want us to find the volume of the sphere, and they give us the surface area. So in order to do that, we're going to have to find R first, then use that in the volume formula of 4/3 pi r cubed. So the surface area is 324, and that formula was 4 pi r squared. So the first thing we're going to do here then is to divide by 4. Well, let's divide by 4 pi. 4 pi. That will give us r squared here. And that is, oops, and this should have a pi in it. Sorry about that. This pi needs to be here. And it gives us 81. So if we take the square root of each side, we're going to find that r is equal to 9. Now that's not our answer. We're just going to put that into this formula now. So our volume is 4/3 times pi times 9 cubed. And we're going to leave that in terms of pi, so that is 972 pi. Remember, it's measured in inches, so it's inches cubed, and it's cubed because it's volume. This next example poses the question, hey, what is the surface area of a sphere? And then they don't give you the volume, they don't give you the radius or the diameter, they give you the area of the great circle, which is 49 pi. So if I have 49 pi, that area of that is a circle, and the area of a circle, remember, is pi r squared. So 49 pi is equal to pi r squared. Oops, and I did that again. Sorry, make that look nice. It's 49 pi. I keep forgetting to put that pi in there. 49 pi. So if I divide by pi, r squared is 49. And you take the square root of each side, r is going to be 7. So now that I have found r, I can find the surface area using the surface area formula, 4 times pi times the radius squared. And that's going to give me 7 squared is 49 times 4 is 196, and that's pi, and that's going to be, is measured in miles squared. So we're going to look at what happens to the effect of the volume if we change the radius by multiplying it by 3/4. So let's look at the original dimensions. We have r is equal to 8, so the volume would be 4/3 pi times 8 cubed, which gives us 2,048 thirds pi centimeters cubed. And then let's multiply that, multiply by 3/4. So we take the radius 8 and we multiply it by 3/4. 4 goes into 4 once and 4 goes into 8 twice. So our radius is 2 times 3, which is 6. So the volume now is going to be 4/3 pi times 6 cubed. And that is going to give us approximately 288 pi centimeters cubed. So if I were to multiply the original 2,048 over 3 pi by 27 over 64, that would give me this 288 pi. So this is what it's being, the volume is multiplied by, volume multiplied by, and that 27 over 64 is 3/4 cubed, which makes sense that it's cubed because this is volume, and volume is cubed units. Okay, in this last example, we're trying to find the surface area and the volume of the composite figure. And we're going to give our, once again, give our answers in terms of pi. Now, we have a cylinder and a hemisphere, and we're going to add them, we're going to calculate them separately and then add them together. So let's first do the surface area. So the surface area of a hemisphere will be 4 pi r squared, but we're going to divide that in half. So it's really, because it's only half of a sphere, so it's going to be 2 pi r squared. Now, the diameter is 12, so the radius is 6. So the surface area of the hemisphere is going to be 2 pi 6 squared. So that's going to give us 72 pi inches squared. Not, yeah, squared. And then, excuse me, the surface area of the cylinder is going to be this part all the way around. So that's going to be the circumference times the height. And then we're going to also have to find the area of that bottom, the base, the circle. So let's first find the height and the circumference. The circumference is going to be 2 pi r, and we're going to multiply that by the height, which is 9. R is 6. So we have 2 pi times 6 times 9. So that's going to give us, we've got 2 times 6 is 12, times 9 is 108 pi, and that's also in inches squared. And now we need that base, which is just a circle, so it's going to be 2 pi r, and pi r squared, we want the area of that. And so that's going to be pi times 6 squared, which gives us 36 inches. I'm sorry, 36 pi inches squared. So we're going to add up these three numbers, 72, 108, and 36. And that's going to give us the grand surface area of being 216 pi inches squared. Now let's attack the surface, or the volume of this. So we want the volume, and this one we don't have to do the hemisphere, it's two parts. We're going to do the hemisphere and the cylinder. So the hemisphere, once again, we have a radius of 6. So the area of the hemisphere, or the volume, I mean, of the hemisphere is going to be 1/2 of 4/3 pi times 6 cubed. So that's going to give us, and if you can use the fraction key on your calculator for these, and you're going to have 144 pi inches cubed. And then we're going to add that to the volume of the cylinder, which is going to be pi r squared times the height. So pi and r is once again 6, so 6 squared. And the height is 9. So that's going to give us 324 pi inches cubed. And then we add those two numbers up together, and the volume then is going to be 468 pi inches cubed.